Imagine looking at a family photo where your great-great-grandfather is somehow younger than his own newborn son. A glitch in the very fabric of reality. This is the headache currently facing modern cosmology, as we stare at a tiny, flickering dot in the constellation Libra known as HD 140283. For over a century, we have watched this Methuselah star zip through our neighborhood at over 1 million kilometers per hour, a lonely celestial wanderer. But when we finally tried to calculate its age, the math returned a result that shouldn't be possible. The star appeared to be 16 billion years old. The problem is that the universe itself, according to our best measurements of the Big Bang's echoes, is only 13.8 billion years old. How can a star exist before the beginning of time, before space itself was stretched out into the vast, dark ocean we see today? This paradox strikes at the heart of our understanding of physics, suggesting that either our cosmic clocks are broken or we've fundamentally misunderstood the universe. To solve this mystery, astronomers like Howard Bond have spent years squinting through the Hubble Space Telescope, trying to find a margin of error. They used the parallax effect, measuring the star's tiny shift against the background of distant galaxies as the Earth orbits the Sun every 6 months. This allowed them to precisely calculate its distance about 190 light-years away and determine its true intrinsic brightness, which is a key clue to its age. You see, stars are like cosmic candles that change their glow as they burn through their primary fuel source, which is mostly simple hydrogen. Initially, scientists calculated age based on nuclear reaction rates, assuming that a dimmer, older star must have been burning for an impossibly long time. But these early estimates were based on a universe that was much simpler than the one we actually inhabit, leading to that staggering 16 billion year figure. As we looked closer, we found a chemical fingerprint hidden in the star's light, a surprising amount of oxygen compared to other heavy elements. In the very early universe, there was almost nothing but hydrogen and helium. Oxygen had to be forged inside the bellies of the very first stars. By accounting for this oxygen, researchers were able to bring the estimate down to 14.46 billion years better, but still older than the universe itself. Even with further refinements bringing it to 14.27 billion years, the Methuselah star remains a stubborn outlier that refuses to fit into our cosmic timeline. We are left with a 200 million year gap that shouldn't exist, a silence in the symphony of the Big Bang that we cannot ignore. This gap has forced us to re-examine the most fundamental number in all of science, the Hubble constant, which describes how fast space is expanding. If the universe is expanding faster than we thought, then it must be younger, making the mystery of the Methuselah star even more terrifying. To understand why this star is such a rebel, we have to look at how we measure the age of everything in existence. For decades, we relied on the Planck Space Telescope to map the cosmic microwave background, the oldest light in the sky. This ancient radiation told us the universe was expanding at about 67 kilometers per second, giving us an age of 13.8 billion years. But when we use a different method, measuring the distance to actual objects like stars and supernovae, the expansion rate jumps to 74 kilometers. If the expansion is faster, the universe must be younger, perhaps as young as 12.7 or even 11.4 billion years old. This Hubble tension creates a crisis. The younger the universe gets, the more impossible the Methuselah star becomes. Imagine a house being built in 1950, but one of its bricks was manufactured in the year 1920. It simply doesn't add up. Some physicists suggest that the speed of the universe's expansion isn't a steady cruise, but rather a chaotic acceleration. This points to a mysterious, invisible hand pushing space apart. Dark energy, a force that accounts for 68% of everything. For a long time, we assumed dark energy was a constant, a fixed property of empty space that never changed its strength. But if the expansion rate is changing, it means dark energy might be evolving or something else is interfering with it. Enter the realm of quantum fields, invisible layers of energy that permeate every inch of the cosmos, from electrons to neutrinos. When physicists try to calculate the total energy of these fields, they get a number that is 120 orders of magnitude too large. This is the greatest mismatch in the history of physics, suggesting we are missing a massive piece of the cosmic puzzle. Researcher Massimo Sordono suggested that an unknown, ghostly particle might be the culprit behind this instability in spacetime. This hypothetical particle is called the axion, a tiny, lightweight entity that may have appeared right after the Big Bang. Axions could act like a hidden seasoning in the cosmic soup, subtly changing how gravity and dark energy interact over billions of years. If axions exist, they could explain why the universe's expansion seems to shift gears, throwing off our age calculations entirely. It would mean that time itself might not flow at the same rate across different eras of the universe's long history. Could 10 minutes at the dawn of time be fundamentally different from 10 minutes in our modern, accelerating 21st century? This inconsistency between the age of the stars and the age of the universe has happened before, specifically in the 1990s. Back then, some calculations suggested stars were 20 billion years old, which was clearly impossible given our data. But as technology improved and our measurement tools became more precise, those massive gaps eventually began to shrink. We filled our knowledge gaps with new theories of stellar evolution and better experimental discoveries about nuclear physics. However, the Methuselah star is different because it persists even after our most advanced telescopes have triple-checked the math. It stands as a silent guardian of a secret that the universe isn't quite ready to reveal to us just yet. Some researchers are now looking even further back, wondering if there was something else before the Big Bang itself. Could the Methuselah star be a relic from a previous version of the universe that survived a cosmic rebirth? This idea, known as the Big Bounce, suggests the universe goes through infinite cycles of expansion and contraction. In this scenario, HD 140283 wouldn't be older than the universe, just older than the current era of spacetime. While this sounds like science fiction, it's a mathematical possibility that physicists are forced to consider to save their models. If we cannot move the star forward in time, and we cannot move the Big Bang back, the bridge must be somewhere else. Every time we think we have mastered the laws of nature, a tiny flickering light in the sky reminds us of our ignorance. We are like detectives arriving at a crime scene billions of years late, trying to reconstruct the story from a few photons. The Methuselah star isn't just a physical object, it's a mirror reflecting the limits of human cognition and our tools. It reminds us that common sense is a local rule that doesn't necessarily apply to the vast, cold scales of eternity. To solve the paradox, we might need a new physics, a fundamental shift in how we perceive gravity and dark energy. Until then, we must sit with the discomfort of knowing that a star exists that seemingly defies the laws of its own house. We continue to monitor the sky, waiting for the next generation of telescopes to catch a glimpse of the missing truth. Because in the end, the universe is under no obligation to make sense to us, it simply is, and we are its witnesses. As we continue our journey through the cosmic dark, we must accept that our maps of the universe are still being drawn. The Methuselah star stands as a monument to the fact that science is not a destination, but a never-ending process of correction. Perhaps the star isn't an impossible ghost, but a beacon pointing us toward a deeper truth about how gravity truly works. It challenges us to rethink the very nature of time, whether it is a steady river or a fluctuating tide influenced by unseen forces. The presence of increased oxygen in its atmosphere tells us that even the oldest objects carry traces of the generations before them. If we eventually find that the universe is indeed younger, we will have to rewrite every textbook on the evolution of galaxies. We might discover that the first stars formed much faster than our current computer simulations have ever dared to predict. Or perhaps dark energy is far more temperamental than we imagined, stretching the void in fits and starts throughout history. This mystery reminds us that the human mind, evolved to find fruit and avoid predators, is now weighing the mass of suns. We are a bridge between the small and the infinite, trying to make sense of a reality that existed long before our ancestors. Every photon from HD 140283 that hits a telescope lens is a message from the dawn of creation, traveling for eons. It has survived the birth and death of countless other stars, witnessing the slow assembly of the cosmos we call home. Whether it is 14 billion years old or slightly less, it remains one of the most senior citizens of our local galactic neighborhood. To study it is to touch the very edge of the beginning, a tangible link to the fires of the Big Bang. As we develop more sensitive instruments, like the James Webb Space Telescope, the shadows of this paradox may finally lift. But for now, we live in a universe that is seemingly younger than its own parts, a beautiful and humbling contradiction. It is a reminder to stay curious, to keep questioning, and to never assume we have seen the final page of the story. The universe is far stranger and more wonderful than our most complex equations can currently capture or describe. So, we will keep looking up, searching for that one piece of evidence that will finally make the cosmic clock stop ticking backward. In a universe of infinite mysteries, perhaps the greatest wonder of all is that we are here to ask the questions.